The graphs of the functions b, g, and r are labeled below. The formulas are provided with subscripted a values. Which of the following statements is false? All right, well, let's start with the first statement here. When x equals 1, are all of these graphs equal? Yes, they are, because right here we see that all three functions go through the same point when x equals 1. So the y value when x equals 1 here is 0, 0, and 0. So these are all equal, and that is true. Moving on to b, we have the y-intercepts, where these graphs intersect the y-axis, and that's when x equals 0. When x equals 0, r is the least value down here with -3, so yes, that's true. B is the middle value at around -1.5, and g has the highest value at about 1.5. So these are also true. Let's skip C for now and move on to D. We can actually solve for these coefficients because we know the vertexes of each of these graphs. Here, the vertex is -1, 2. Here, it's -1, -2. And here, it's -1, -4. So using these x and y values, we can solve for the a portion here. So let's start with b of x. So we have b of x, we have a, b, which is what we're solving for, times x plus 3, and for b, x is -1, which actually it is for all of the graphs, which will make our lives easier. So we have -1 plus 3, which is 2, times -1 minus 1, which is -2. So we have -4 ab equals, and what is the y value? -2. So for AB, we have AB equals to -2 over -4, which is +1/2. So we see that that is our value here, 1/2. Now we can erase this and move on, but as you can see, because the x value is the same in the other ones, and all that changes is the y value, we can actually reuse a lot of what we've done here already. So -4 ag, so all we've changed is that now we're solving for this instead of this, equals, and what's the y coordinate here? +2. So we see that ag equals -1/2. -1/2. Because we're still using -1 as our x, so the only thing that is changing is the output, the y value, and the coordinate here, the a coefficient. All right, and then finally we have AR. So -4, which is the same as all the others because it's -1 plus 3 times -1 minus 1. So -4 AR equals, and our y coordinate here is -4. So AR equals 1. 1. So the smallest of the coefficients is AG, so that's true at -1/2. Then we have AB and then AR. So this is true. Now, C is our answer here. C is false because this does not hold true for all x values. Between -3 and 1, this is true. R is the smallest. At any x value, the y value on R is going to be smaller than for B or G, and G is the greatest. So for example, at x equals -2, R is way down at -3, B is at -2.5, or -1.5, and G is all the way up at +1.5. So you can see that this does hold true. However, if your x value is less than -3 or greater than 1, you see that these switch positions. All of a sudden, G will be the lowest value. And so because it doesn't hold true over all x values, this is our answer here, C.